Good morning. Today I'm going to show you how to set up and use the soil testing kit called the Rapitest Soil Testing Kit with your students. Now I'm at home in my backyard because of COVID, so I can't use a lab table to show you, but the testing kit that's made by Rapitest is a layperson kit that is really convenient to use with students, and they get good science out of it. So when you're testing kit, you're going to have these 4 testing vials here. You're going to have some reference sheets and some directions, and you're going to have some capsules, and it may or may not come with a pipette, but these are easy enough to obtain. So at home versus the classroom, I'm going to show you how to try this out at home and then how I use it in the classroom. So the first thing that kids need is a soil sample. I usually have kids bring in a soil sample, so I tell them to go out to their backyards or to the park if they don't have a backyard. Some of them get it at school, so at brunch or lunch they come and borrow one of my spades. They go out and take a soil sample at school, that's fine. I would say half of my groups do that because they forget to get one from home, so they get it from the school. The school soil is pretty terrible, so I tell them ahead of time, you want to get it from home because it's way more interesting, your sample from home, than it is from school. Okay, so I tell them that they need to dig several inches deep because they don't want the top layer of soil, because they want what the roots have. We also don't want that O layer of soil, we want the A layer, which is the top soil. So I have them dig a few inches down, and this just get a shovel full, they don't need very much, and bring it in a Ziploc bag. I took a few soil samples this morning at the community garden. So because I have kind of a patio backyard here in Southern California, my family, my husband and I and my kids, we also have a community garden plot at one of the local city parks. And so I took some soil samples today from there. I'm just going to test my soil and make sure it has the right nutrients. I haven't done this for over a year, so it needs to be done. And then I took a couple samples from a teacher friend. So one of my teacher friends who teaches special ed and not science, she and her husband just got a plot at the community garden as well, and she doesn't know anything about soil, so I volunteered to test it for her and to see what they need to do to amend the soil. You can see that they're a little bit different colors. So because I'm an APES teacher, I do know a little bit about soil, so my husband and I spent a long time amending and getting the soil great in our plot. So this is our plot soil, this is her plot soil that she just took over from somebody, and you can see there's a dramatic difference in color. My plot is a lot darker than her plot because somebody had it, they've neglected their plot for a little while. And so you can see that color makes a difference. That is an indicator of soil health. The darker it is, mostly it's better. Not always, but mostly. And so this is a darker color than this one, and I know it's hard to see with the video. All right, so when kids bring in a soil sample, the first thing that they need to do is they need to spread it out to dry. We want dry soil for this test. So this test is run over 3 days if you're not on block schedule. Now it doesn't take that long. The first day, you just have their kids spend 10 minutes in lab, and on a paper towel, they're going to spread out their soil sample and let it dry. And they don't need that much soil in the soil sample. And they're going to let their soil sample dry. And they need to make sure that they label their paper towel. Let me show you that paper towel. All right, so now you have a table view here. And so in this paper towel right here, I just poured out what was in my baggie. And it was baggie B. So I know the location of baggie B. For students, I have them label the paper towel and leave it on a lab table or some sort of table overnight. Now they also need to break up clumps, so that's kind of fun for them to break up clumps and remove rocks. And and they can just put the rocks back outside or in a container that you have in your classroom if you don't have outside doors. And they're just gonna let it dry overnight. And that should only take about 10 minutes of time on the first day. If you are on block schedule, you might do this at the beginning of the period and then do the next step at the end of the period. So it doesn't have to be perfectly dry, but as dry as they can get it. Okay, so after we've let our soil samples dry out, and I'm going to carry on here with you, but again, I would probably let these dry overnight, so do this at the very end of a period and then come back the next day to do the next step. So let's talk a little bit about soil sampling. I just have a spade here because this is the most common thing that kids might have lying around. If they don't have a spade at home because they're not gardeners, they don't have a yard, this is very new to a lot of our students, then sometimes I say ask your mom for an old wooden spoon in the kitchen or something that you could dig up a soil sample. One caution for those of you who live in states where the ground freezes, you will need to do this earlier in the year versus later. So soil sampling comes in Unit 4 in the CED, and some teachers actually start with that unit first because they want to do the earth science stuff at the beginning of the course. Or in Unit 1, we talk about the biogeochemical cycles, and in the nitrogen cycle, soil is really important. Well, in all the cycles it's important, but in soil sampling and chemical of soil tests, we take our nitrogen test here. And so if you are in a place where it gets really cold and you don't want the kids to go outside and the ground is frozen later on in the year, then you can put soil sampling in Unit 1 when you study the nitrogen cycle. Now you'll also study these other things, but just kind of tell the kids ahead of time that you'll learn this stuff again in Unit 4, but because of weather situations, you need to do the soil testing lab now. There are also soil sampling tubes. I started out with them, but they bust pretty easily and kids don't know how to use them very well. It is what the professionals use, so you could get some soil sampling tubes. Over the years, I've just found that the spades are just a lot easier for the kids and they're a lot cheaper for me. I have a bunch in my classroom, and again, kids can on brunch or lunch go out on campus, borrow a spade from me, and get a sample of soil from campus if they don't get one from home. Okay. The next thing they're going to do after this is dried out, so preferably the next day, is we need to mix 1 part soil with 4 parts water. So at home, you can just get some cups. Now, you don't have to do 4 soil samples like I have here. You can just take 1 from somewhere, and you just need 1 paper cup at home or plastic cup. In the classroom, I use plastic beakers. You could use glass, but the little pebbles and rocks scratch up the glass, so it isn't something I necessarily recommend. So let's say we have our soil sample D here. The kids should not really have rocks in their soil sample, so try to get rid of the rocks. And what they're going to do is 1 part soil to 4 parts water. And this is what I call a layperson's test. So at home, and I talk to my students about this, this is what's called a layperson test. And I talk to my students about what that means because a layperson as a non-professional is a new term for most of them. And so I say that this kit is designed that you can go buy it at the hardware store, you can buy it at Walmart in the garden section, and the average person can do it. The average person doesn't have a graduated cylinder at home, so what are they going to do? So a lot of times kids will say, well, they might use a measuring container from their kitchen, and yes, people at home do that. So for us here, you can at home, you can measure using just a measuring cup like this. So maybe a 1/4 cup soil and a cup of water would be a good amount to use. I have a spoon here, I can kind of spoon it in. And I would just stick this in the dishwasher when I'm done so it can get all sterile so I can use it for food again. Normally in science, we don't mix up our, you know, chemicals and things, but these aren't chemicals. It's just soil. Don't get your soil from a location where maybe animals have defecated. So, you know, and then anyway, I'm gonna sterilize this when I'm done. So I'm gonna go ahead and pour it in my cup, about a 1/4 cup of soil. Now this is not precise. We know in science that I just measured a dry substance in here and not a liquid. And so that's gonna be off, and discuss that with your students a little bit. Even when you go the plastic beaker route, so this is a 500 ml plastic beaker. So my students would put 100 milliliters of their soil sample here and then to 500 with water. And we talk about the accuracy here. And I talk about how it's a layperson's test, that people, the average person is not going to know that much about the differences with volumes versus mass and things like that. And so the test is designed so that people can do it at home without graduated cylinders, without balances. And so the test will give us results without being totally precise. But we do talk about the importance of precision if we were publishing these results, if we were going to compare them around the country. We would have to use better techniques than this. Okay. So now I'm going to use water. Now again, this testing kit, I'm looking for my water. Okay, so this testing kit is made again for the average person at home that's not going to have distilled water. So it's not a requirement that you have distilled water. We do talk a little bit about what could be in the water that could influence the results. For example, this is tap water from my home. Sometimes when we do water testing, we get about 3 ppm of nitrates in our tap water. The EPA limit is 10, so it's way under EPA limit, but what does exist in our tap water sometimes, not always. Our tap water, half of it comes from groundwater and half from the California aqueduct, which goes from Northern California to Southern California through agricultural land in California Central Valley. And so you have all of that agriculture fertilizer washing in to the open aqueduct. Not a lot, it is raised, so not a lot get in there, but sometimes it does. So that's where they think possibly the nitrates could come from. But in any case, our tap water does have a little bit of nitrates in it. So we can bring that up with students, can make all these connections and apes together. So ideally, we would want to use distilled or purified water for this. But again, this is made for the average person at home. It's not going to affect our results that much using tap water. So at home, you can use tap water. So I'm going to go ahead and add a cup of tap water here. It barely fit. And then I'm going to make sure I label. Now again, if you're just doing one soil sample, you don't need to label, but because I'm doing my community garden plot, I'm going to label this D because I know where D came from. So what we want to do is we want to stir it all the way up. So we want the ions that are in the soil to come out into the water. So I tell the kids to stir a minute or two, set a timer, stir, 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 stir. And then we have to let it settle. It takes about an hour to settle. And it's really important that once they've stirred it up and they're done, they do not disturb it, because when we do 3 of these tests, the nitrogen, the phosphorus, and the potassium, we are going to use the water solution on top. So the soil is going to settle to the bottom and we want the solution on top. So the ions of nitrogen, phosphorus, potassium are going to rise into the solution here into the water. The only test that's different, and I tell kids, okay, once you're done here, don't throw this all away or don't go dump it outside, because you need a little bit of the actual soil for the pH. So pH is done differently, and you absolutely need distilled water for this pH test. So there's a line here that says fill with soil. And so I give them a little plastic spoon, which I reuse from year to year, and they're gonna fill it here with soil. And we'll get to this test later. There's a little line on here that says fill with soil. So if you have one class, you can just have them fill this and wait till an hour or the next day, and then they can dispose of this. For my classes, since I have multiple classes, they're all going to share these things, so they have to leave this paper towel of soil until you're done with all of the tests. So they're not done with this yet, because they'll need some of it to fill this in an hour or the next day. Okay, so if you are on a regular schedule, traditional schedule of 45 to 55 minutes each day, then you want this to be day 2. So day 1 was spreading it out to dry. This is day 2. And then overnight it'll settle, because it takes about an hour. And then the next day in lab, you will run these tests. So it's over a 3-day period of time. If you are on block schedule, I recommend that you spread it out to dry at the end of one period, and then at the beginning of your next block, you do this part in the cup, wait an hour, and then do these. Or you could wait till the next block as well. It won't hurt anything to wait. All right, so once this has settled, then we can do our next tests. So I'll see you when that happens. All right, so I'm gonna switch to an overhead view here. We've waited some time. I actually waited overnight to let the soil settle here. And so we're gonna do the next part of this lab. So I'm gonna put a clean paper towel here to make it a little bit easier for us to see what's going on. So we have this cup here, and one of the things that's really important for students to know is they are not to disturb it, they are not to stir it up. So sometimes I remove the spoon away so nobody stirs it up. I've had kids, even though I've told them several times, don't stir it, they stir it. So I try and say, don't disturb the waters, you know, from Lord of the Rings, Fellowship of the Ring, in front of Mines of Moria. Some kids get the analogy, some do not. So sometimes there's some floating stuff at the top, which this one doesn't have very much, so it's fine. Again, the spoon is a little bit dangerous because you don't want kids to stir it back up. So we have our 4 tests here, and 3 of the tests do the same thing, but the pH is different. So we have our capsules, and what I do with the capsules is that over the years, I've saved these little tiny baggies. And so I have my student lab assistants put one of each color in these little baggies here. And then each group of kids gets the 4 of these, and then a set of 4 different colors. The kids will joke about, you know, are they edible and all of that stuff. You just have to take care of that. Okay, so let's do first the NPK test. So we have N, P, and K here. And so what you need to do is you're going to use a pipette and you want the liquid on top. So I teach my kids that they need to go beneath this sort of floating stuff to right about here, and then they can squeeze up to get a sample like that. And then you're going to get mostly water and not any other kinds of detritus in here. So that's a skill with pipette. A lot of kids don't know that a lot of kids will squeeze it ahead of time, which is okay, but you don't unsqueeze until you are in that part of the water. And so now we're going to fill these 3 tests. They're very easy to spill, so tell the kids to be careful. Now on the back, so this is the front, and this is the back, and there's a large chamber and a small chamber. And so the large chamber is actually to put the capsules in for storage. So I tell the kids that at home, if you're doing a soil test, this is supposed to be for extra storage. We don't use it for the actual test. We're going to use the small side. So with the pipette, they need to fill up just the small size of the container. And there is a fill line on the other side. It has a dot right here, dot, 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 and there's the fill line. Okay, then they're going to carefully take a capsule and open it up. No matter how much it's bold in the directions and how much I tell them, you're still going to have a kid put a whole capsule in, and then they've ruined your capsule, but that's okay. We all make mistakes. So they have to carefully open and try not to spill. If they spill a little bit, it's fine. It's not going to ruin it. So they're going to pour in the capsule in here. They're going to put the lid on, and then they're going to shake it for about a minute till all the powder dissolves, and then they're going to wait for a color change. So our water here had a little bit of brown tinge to start, so it's going to be a little bit challenging to check for the color change, but that's okay. All right, so I noticed the color when it went in, and this is how you can kind of tell. Well, actually, one other trick that you can do sometimes if you have a little bit brown water is if you fill up the other side, it will put that color tinge in the other side. So then you can kind of see what the color change is supposed to look like here. So if I fill this up all the way with the brownish water, and then you have to wait about 5 to 10 minutes. I don't remember, it's on the instructions, but you have to wait for a color change. So let's talk about logistics in a classroom. So in a classroom, what I've always done was I had the funds immediately to purchase a set of these 4 for each of my groups, my lab groups. So I have 9 lab groups typically in a class, and so I have 9 sets of these testing kits. And then every year I buy replacement capsules for them. If you don't quite have the budget, and let's say you have 8 groups, you could buy 2 of these kits and rotate these around. The problem is it takes more time because you have to wait for a color change. All right, so we're going to wait for the color change for the nitrogen. And then let's go ahead and fill in our phosphorus. All right, let's talk about the pH now. So pH is different. Now for this, you're gonna really want distilled water. If at home, when you're practicing this at home, you don't have distilled water, just use tap. You're just practicing with it. Or you can use filtered water like bottled water or from like a Brita filter or something like that. It's really, again, trying this out. It's not that big of a deal. So I'm going to go ahead, and we had dirt we already put, but let me just go back and remind you that we filled here with the actual soil sample. And then we're gonna put water to the top. And I'm just gonna use tap water for right now, just to show you how it's done. Got a little bit too much in it. Okay, and now I'm gonna add a green capsule in here. And this one should give you more of a dramatic change in color with the yellows and the greens. Okay, my phosphorus needs to be shooken up again. This is the one I told you has a hard time dissolving all the way. So I tell kids to especially shake your phosphorus. Okay, I'm gonna shake everything back up. Sometimes it doesn't dissolve completely. All right, so now we wait until we get a color change for all of these. Now I have them laid out here for you, but you know, tell the kids try and keep them upright so they don't leak. All right, and we'll come back and check the colors in about 10 minutes. Let's go over the results now. So sometimes kids need a little bit of help with this because sometimes it's in between a certain color, and sometimes the tablet, the white powder, especially if they're old, sometimes they're a little bit brown, and so I tell kids that you do the best you can. I'm not going to mark you down if you choose adequate and I think it's sufficient. So just assure them of that, especially AP kids want to make sure they get it right. But let's start with pH here. So you also want to teach them to hold it up to the light. So I have windows in my lab so they can hold it up to the window. And to me, it's kind of between 7 and 7.5. It's pretty dark, and that's normal. So I am west of the Rocky Mountains, and so typically, not every soil, but typically our soil is alkaline. I'm also in the chaparral biome, and so our soil here tends to be alkaline. And so it doesn't surprise me. I have never had a student bring in soil that is acidic. Maybe 6.5, but almost every soil sample that kids bring in, even the stuff that they buy, potting soil or garden soil at the hardware store, the garden store, usually you have your greens up here. But depending on what state you're in, you might get some acidic soils. Okay, and then the next one, our potassium is pretty high. So I would say that this is either sufficient or surplus. So the kids, I would tell them to make the call. They're gonna call me over and they're like, we can't tell the difference. And so I'd say, well, I think you can make a case for either. It's kind of in between. So, so good on the potassium. The phosphorus too. Now, so the phosphorus is a little bit of gray, and I did put more of the solution in this side to sort of help with the color change a little bit. It also, again, this is the phosphorus, so it doesn't dissolve as well. So sometimes they have to keep shaking it up to get the tinges of blue. And so in my opinion, it is, even though it's dark on this side, we want to look at shades of blue mostly. And so I think it's between adequate and sufficient if we're looking at the shades of blue versus the shades of brown. And so that's okay for the potassium. Okay, so the nitrogen, now this is a garden plot, so a lot of times people have sufficient nitrogen if they have chicken manure or things like this, but this plot ran out of nitrogen. And so this has a lot of shades of brown, so this one's the hardest to sort of interpret for students. So I said, if you just look at the tinges of pink, what's it mostly like? And in my opinion, the tinges of pink most match deficient or depleted for the nitrogen. And that is logical in a garden plot where people grew and then they sort of neglected and didn't fertilize, because most of our green leafy growth comes here. Especially This is May, and if they grew winter vegetables, which is basically green leafy growth, so we can grow our winter crops here in Southern California. We can grow our broccoli and our lettuces and chard and cabbages. That's really all green leafy growth. So it does not surprise me it's deficient in nitrogen. Okay, so now what students do, and they can actually start the questions while they're waiting for the color change. So in the Rapitest kit is a bunch of reference sheets, and so what I do with the reference sheets is I highlight some of the places where they can find the answers to the questions for the lab. The importance of nitrogen, the importance of phosphorus, the importance of potassium, and well, let's talk about potassium real quick. Potash is just kind of a nickname, a farmer term for potassium. And then why would you want to know your pH as well? And so those questions are in the reference sheets, and they can actually work on those questions while they're waiting for the color change. For cleanup, this is not anything that's hazardous. Again, it is something that can be used at home, so the cleanup is fairly simple and easy on these. I have them rinse out, turn over to dry for the next period. The next period when they come in, it can be wet, it's fine, it doesn't really matter. And that's it for Rapitest soil testing.